The F-16 Fighting Falcon is a lightweight multi-role fighter that is highly maneuverable in air-to-air combat and air-to-ground attack. Designed as a high-performance, cost-effective combat weapon, it's in use by 25 nations around the world. Don't let its small size fool you. The F-16 employs advanced aerospace engineering and flight control systems and can withstand over 9 Gs, more than any other current fighter. I'm Paul Max Moga, and I've flown some of the most sophisticated planes ever built. I'm at Langley Air Force Base in Hampton, Virginia, the first U.S. military base built specifically for air power. On this episode of Great Planes, we'll learn the amazing story of the F-16 Fighting Falcon. Lieutenant Colonel Bob Ghost Gray flew the F-16 here in Virginia. Well, Ghost, I appreciate you taking a couple of minutes to talk to us about the F-16 today. Tell me a little bit about what you know about the history of this jet as far as why did the Air Force need the plane in the first place?
Max, the F-16 was a response to the cost and complexity of the F-15. So they came up with the lightweight fighter concept. And what resulted from that was the F-16. The goal was lightweight, low cost, minimal complexity airplane that they could put a lot up of rather than a few very complex and capable airplanes.
The F-16 entered service in 1979, packing Mach 2 speed, agility, and high-tech features into a lightweight fuselage. Equally incredible is that the creation of the F-16 utilizes a new design process that hasn't been used on a fighter before. It represents the latest technology available to military aviation anywhere. It can handle almost any kind of mission with more comfort and ease than any other fighter. Many see the F-16 as the ultimate dogfighter, a culmination of 60 years of fighter development. When World War II reunites enemy nations, they quickly learn that the opposition's fighters are faster, more heavily armored, and have deadly effect. The need for a superior aircraft is fueled by the ongoing conflict. Several nations in the conflict experiment with jet power, and by the end of the war, the Allies and Germans are building the first fighter jets. Nazi leaders recognize the importance of air power, and their financial contributions generate several breakthroughs in jet research. German designers are the first to raise the issue of compressibility, the drag and control problems encountered at high speed. Nazi engineers experiment with swept-back wing designs to reduce drag. The first U.S. jet takes flight in 1942. The Bell 59 Aerocomet is built around the Whittle turbojet, but its performance is inferior to other fighters, and production is canceled by 1944. The output of early engines is low and requires at least 2 power plants to achieve reasonable performance. While jet engine development radically progresses, many of the first fighter jets fail because the conventional airframe cannot equip a turbojet engine. The Republic F-84 is introduced with the same straight wings and tail of a World War II fighter, and several early flight tests result in fatal crashes. The jet has so many structural and engine problems that in the first year of service, the Air Force considers scrubbing the program. In spite of complications, studies continue and perseverance pays off when a possible solution comes from the North American Aviation Company. After studying information captured from the Germans at the end of the war, they proposed that swept-back wings may decrease drag on a plane traveling at high speeds. The U.S. Army Air Corps ends a 40-year association with the Army and becomes the U.S. Air Force in 1947. The new Air Force focuses on jet research during this new era of aviation, where air power is a major element of defense and a primary hope for deterring war. Their tests confirm that the swept-back wing surface adds speed without reducing the aircraft's stability, and America's first swept-wing fighter, the F-86 Sabre, emerges for combat in 1950. The Sabre distinguishes itself in the Korean War as an excellent aircraft, with high-speed maneuverability and firepower. But America is not the only country developing the swept-back wing design. The Russians have also been using German innovation to manufacture their own jets with swept-back wings. The most famous is the MiG-15. It shocks the West out of its complacency once it first appears over Korea in 1949. On June 27, 1950, the U.S. Air Force deploys to fight as an individual arm in the military for the first time. While the F-86 Sabre cannot match the MiG-15 in some performance areas, Sabre pilots use superior flight tactics to achieve a 10-to-1 kill ratio over MiGs in Korean dogfights. The U.S. finds success with this combination of experience and technology, but when the conflict ends in 1953, it seems that the time for the dogfighter is about to run out. During the Cold War, the role of American fighter aircraft is to destroy long-range Russian bombers that threaten nuclear attack. The Sabre's machine guns are not the best weapons to use against these aircraft, and are soon replaced by missiles, developed for air-to-air and air-to-ground use. As their sophistication improves, the fighter's role diminishes to a platform for launching missiles. In 1965, the United States commits air power to the Vietnam conflict. While fighter bombers are effective in the ground attack role, they are not dogfighters. When the North Vietnamese MiGs appear, the faster and more sophisticated American fighter bombers are not agile enough to bring them down. The MiG-21's maneuverability and speed make it one of the most widely used fighters in the world. The model is only a slight improvement to the MiG-15s used in the Korean War, but the agile fighters are heavily armed and more dangerous than ever. The Vietnam skies present another challenge with a change in the rules of engagement. This requires U.S. pilots to closely identify their target before weapon release. The previous tactics of long-range missile attack are useless, and pilots must develop new strategies. While developing high-speed missile platforms, a truly versatile aircraft evolves. The McDonnell F-4 Phantom revolutionizes aerial combat with its sophisticated radar and deadly air-to-air missiles. But the F-4 is never a true dogfighter, and the combination of Mach 2 speed and maneuverability is only a temporary answer to the deadly MiG. The Navy soon finds a replacement that revives the concept of a dual-role attack fighter. On November 22, 1961, the F-4 Phantom breaks the world speed record, flying at 1,606 miles per hour. In the late 1960s, the United States Navy and Air Force worked to fill the void created by the lack of a high-agility dogfighter. The Navy announces a design contest among manufacturers for a new plane to replace the F-4 Phantom. In 1969, they adopt the Grumman Corporation's sophisticated but expensive approach and develop an aircraft that can successfully perform two different types of missions. The Grumman F-14 Tomcat is a twin-engine aircraft with variable swept wings that adjust to suit the type of mission it is required to perform. With the wings swept back in a delta configuration, it can reach 1,585 miles per hour and climb at 50,000 feet per minute. With the wings set forward, it can achieve greater agility and, despite its considerable size, outmaneuver much smaller aircraft. This versatile jet can still fulfill the important Cold War role as an aircraft that launches long-range guided missiles that are highly accurate. The Air Force, however, has a less diverse mission requirement and looks toward the fixed-wing design that McDonnell Douglas offers in the F-15 Eagle. The F-15 Eagle embodies knowledge from Vietnam air combat to create a fast and agile fighter. This single-seat, high-performance fighter is without a doubt the best dedicated dogfighter in service. But while the Eagle excels in the skies, cost makes it virtually impossible to equip every Air Force squadron. The U.S. military needs an economical, high-performance fighter that can be built in sufficient numbers to compete with the Soviet threat. And military top brass are not alone in recognizing this need. After serving in the Korean War, fighter tactics instructor Colonel John Boyd launches his own research to develop the necessary fighter. Colonel Boyd flew at the U.S. Air Force Weapons School at Nellis Air Force Base and became well known for defeating all challengers in air-to-air combat in 40 seconds or less. He gained further respect with the U.S. Air Force when he developed the aerial attack study, which turned the art of dogfighting into a science. Colonel Boyd works with mathematician Thomas Christie to develop the now famous energy maneuverability theory. This groundbreaking work enables fighter pilots to evaluate their energy potential at any altitude and in any maneuver, as well as the energy potential of their aerial adversary. Colonel Boyd goes on to show how his theory can be used as an effective tool for designing new fighter aircraft. The approach emphasizes an aircraft